all of this out. What we're going to do first is we're going to focus on function f, which is x squared, and function g, which is x squared plus 3. So for your test, you're going to be asked, what is the transformation that occurs from f to g? Well, we can easily tell what the difference is between them, right? They both have x squareds, and they both have a plus 3. So we want to identify the transformation. I was going to have you graph it by hand, but we're not going to graph it by hand. So if you go to Desmos, in line 1, we can type it in function notation. Desmos is not afraid of function notation. F of x equals x. And then how do we get a squared? Well, you can either show the keypad and actually hit the squared button, the a squared, or you can hit shift and the number 6, and that'll pop you up. And then hit enter to go down to line 2. G of x is equal to x squared. Make sure you hit your down arrow, or your right arrow, to move the cursor down, plus 3. So what's happening? What would be the transformation? It's going up how many units? From blue to green. I don't know what colors yours has. How many units? 3 units. Hence the plus 3. If we change that plus 3 to a minus 3, what do you think would happen to the green graph? It's going to go down 3 units, right? All right, so this is called a translation. What's another fancy word instead of using up and down? Starts with a V. Vertical. So, vertical translation. Get this in your notes. Is our first type of transformation. So a vertical translation is something that is either going to go up or it's going to go down. On your parent graph. It's called parent graph, the most simplest form. Right now, f is our parent graph. So if we have f of x, or sorry, not y, let's do y. Y is equal to f of x plus k. If k is positive, where's my graph going to move? Up or down? Up. So if k is greater than 0, it's going to translate up k units. If k is negative, so less than 0, it's going to translate down k units. Oops, unites. Okay. So a vertical translation is probably the easiest one to see because it either is going up or it's going down. So you have whatever your parent graph is. Here in this case it's x squared. What if we went and changed it? So x out the g of x, go up to f of x, clear that out. And let's do the absolute value. So if you go to the keypad, show keypad, do you see the absolute value sign right here, lower left? If you click on that, we did the absolute value of x. Well, there's my original. Change this to the absolute value of x. And then the absolute value of x plus 3 for function g. Well, what do you think is going to happen to our graph? Missing an equals. What happened to the v?
How do we get out of the absolute value?
Right arrow. Just hit the right arrow. It should move you out. Yeah. It's still shifting up 3, right? So the transformation is staying the same no matter what the function is that is right here. Okay? So absolute value looks like a v. What would be the transformation if this was a minus 20?
Go down 20.
It would go down 20 units. Okay, we can't really see that. What if I changed it from absolute value to square root? Hit the square root button and do the square root of x. And change all of your absolute values to the square roots of x. Do the transformations stay the same? That's what we're doing, plus 30. Did I still translate up 3 units?
Yes.
Yes. So here we had our original square root graph, and it shifted up 3 units. Okay? So vertical translations are the easiest ones to see because it's just whether there is a plus or a minus outside of whatever the original function is. Okay? Questions with that one? All right, so
And you
now,
know the square root sign.
right here. Got it? Okay, so let's look at horizontal translations. All right, so horizontal translations. Let's go back to, clear out the G, go back to the F. All right, let's retype in our x squared. There's our original x squared. Now I want to move it horizontally. So I want to shift it either to the right or to the left. Horizontal movement. If I wanted to shift it to the right, let's say 4 units, what do you think you would have to do to that? If I do a plus 4, don't do this, what happens? It goes up. So that's not what I want to do. So g of x is equal to x squared. I want to move it to the right 4 units. You ready for the magic? Put your cursor in front of your x in function g, put a parenthesis. Put your cursor after the x and put a minus 4. We got to move that square to the outside. So now I have g of x is equal to the quantity x minus 4 squared. So here's our next example. We have x squared and x minus 4 squared. If I'm subtracting 4 from my x, it moves it to the right. And this is what makes it really confusing. It moves it to the right 4. If I add it, another line, so let's make h of x, and I did x plus 4 squared, where does it move h? To the left. So it's kind of actually opposite of what you think it would be. Translating up and down, positive goes up, negative goes down. Translating right or left, negative moves right, and positive moves left. That makes it a little bit confusing. So how do we write that? If we have y is equal to f of, let's say, x minus h. Bless you. So if it starts out standard with an h, if your h is a positive number, it's going to move what direction? It's already minus, so minus something. It's going to move it to the right.
Be left if it's positive.
Well, if it's minus a positive, so it wouldn't change too. If it's it's kind of like y minus y sub 1 equals m. If it's positive, it stays a minus. If it's negative, it goes to a positive. How would you guys like me to write it? Minus and then a plus, just write it 2 different times,
Yeah.
which would make more sense to you guys. So if it's this case, it's going to move right h units. If it's y equals f of x plus h, it's going to move, I don't write, looks like more, move. So it's going to move left h units. That'll make a little bit more sense. Okay. So, same thing would apply if we turned all of those into absolute values. So if I turn it into the absolute value of x, I think if I just highlight it and put absolute value, it'll do that for me. Absolute value, highlight absolute value. Oops, get rid of my squares. Don't want those in there. Doesn't like it. There we go. Okay, so the same thing works for absolute value. If I have my normal absolute value of x right in the middle, if I add a -4 inside, it's going to shift it to the right 4 units. If I have a +4 inside, it's going to shift it to the left. Okay, so let me give you a quick example to do without having to graph it. So example, describe, if I can spell, the transformation from f to g. So f of x is equal to the square root of x. G of x is equal to the square root of x minus 3 plus 2. So think about what will be happening from f to g. Two different transformations. What are they?
Is the 2 not included in the square root?
It is not included in the square root, correct. I need to get our markers. So the -3 underneath the square root is going to move it where? To the right 3 units. So we're going to translate right 3 units. That's weird I. And then the +2 is going to have us do what? Translate up 2 units. Good. Okay. All right, so there's our left and right movement. There's our up and down movement. Questions with that? All right, we got 3 more. We got stretches and compressions. All right, so vertical, stretch, compression. All right, so let's clear out everything but our f. You don't have it in absolute value, put it in absolute value. We'll look at that one. Okay, so what if I made g of x equal to 4 times the absolute value of x? What happened? It changed the slope, right? Here our slope was up 1 over 1, up 1 over 1. Here our slope turned into up 4 over 1. So if I had to think about it as a stretch or a compression, which would it be?
Stretch.
It would be a stretch. So think about, you were to stretch your arms up to the sky vertically. Okay, it's getting more seat. Compression, if you want to compress something down vertically, you're pushing it down. So let's make a third function, function h. H of x, oops, Let's equal that to 1/3. So hit 1 and then you hit the / button and it'll make a fraction for you. Times the absolute value of x. What happened there? Did it stretch or compress from the original? It compressed, right? Okay, so what's our theory? If we have y is equal to some number, a, times f of x, what does that number a need to be for it to be a stretch?
Greater than 0.
Not necessarily greater than 0, because 1 is greater than
Not a
0.
function.
If it was 1, it'd be the same thing. So it has to be greater than 1. So when your a is greater than 1, it's going to be a vertical stretch. If your a is between 0 and 1, making it a fraction, it's going to be a vertical compression. Okay. So, vertical stretches, vertical compressions. Now, the reason why I have a in between 0 and 1, what happens to all of these if I put negatives in front of all of them? If I put a negative there, put a negative there,
It goes down.
a negative there, what's happening? What's a geometric term for that?
Rotation.
Reflection.
It's a reflection over which axis? Over the x-axis. Okay, so we'll get to that in a second. Let's do our horizontal stretches and compressions. So that's why we had to make sure that we had it between 0 and 1. All right, so horizontal stretch, compression. All right. Let's go back to that f of absolute value of x. Hit enter. Let's make a new function, g of x equals. Now I want to put inside my absolute value, let's do 3x and h of x, oops, equals the absolute value of, let's do 1/2 x. Oops, that's not what we want. Did anything change in this case from the last one? We still have a stretch occurring where? The stretch is still occurring with the g, right? But now let's think about it horizontally, because the horizontal occurs when the number's inside. I know it gets kind of confusing, though it looks the same. If I think about this as my horizontal, so this is my horizontal. If I were to stretch for my horizontal, would the purple or the green be stretching versus compressing?
The purple.
The purple would be stretching in this case, right? Does everybody see that? If I think horizontally, I'm stretching, so it's kind of opposite ones in the inside. And I'm compressing, you guys can see that green? I'm compressing the green away from the horizontal, from my x-axis. Does everybody see that? So it's kind of reverse. So for a vertical or a horizontal stretch, that's when your a times your x is happening inside whatever that function is. And in this case, when your a is larger than 1, it's a horizontal compression. And when your A is between 0 and 1, it's a horizontal stretch. Okay. So, if I gave you this example, same directions. If f of x is equal to x squared, and I gave you g of x is equal to 3x squared, what would be the transformation? Ben?
Well, would it be a horizontal compression? Without one.
Be careful. There's a difference between that and this.
Yeah,
Oh,
that doesn't,
so it would
okay.
be a vertical?
Yeah.
A vertical.
So this would be a vertical stretch, as opposed to if we had added an h, which was 3x squared, because now the 3 is being incorporated in the actual function, then it would be a horizontal compression. Okay. All right, last two, let's get these reflections down. All right, so reflections. We had y is equal to negative f of x. Where does it reflect to? So you can just watch. If I had the absolute value of x, and I put a negative in front, it reflects it, right? If I had the square root of x, and I put a negative in front, it reflects it, again, over the x-axis. If I had x squared, and I made it a negative x squared, it's reflecting it over the x-axis. So if you have a negative in front, it's a reflection over the x-axis. What if that negative was inside? So that means I'm going to put this part in parentheses. What happened? Nothing. So it really reflected what?
The y.
Over the y, because it just reflected onto itself. If we look at the square root, so square root of x, and then I do the square root of negative x, that one's a little easier to see. It reflected over the y. If I did the absolute value of x and the absolute value of negative x, again, it reflects over the y, it's just reflecting onto itself. So if the negative is occurring inside with the function, it's a reflection over the y-axis. Okay? Alright, so I've got some for you guys to try on your own. We're done with the computers. Just log out, close them up. Away here in a second. Sorry, Josh. All right, take a few minutes to go through these and decide what the transformation information that is occurring from the parent graph. They give you F, and then they just give you a bunch of G's. Take a few minutes, and then we'll go over it together. Abbreviate, say up to write 3, and you want to eliminate the word translate for today's purpose, feel free.
You go to the doctor this year?
I didn't go to the doctors. I try not to go to the doctor. Plus, my doctor was only open until 1:30.
What time do you leave?
I left during 4th period. Made it to there.
Who taught in the 6th period?
They went to some other study hall, I think, because of the calf. They didn't let me put them in lunch.
20?
Yep.
Okay.
Yeah, the only ones that would really matter is if you do stretch and compression, you need to specify whether it's horizontal or vertical stretch and compression. Yep, it is.
Is that supposed to be the same?
Yeah, I think so. Yeah, number 3 is supposed to be an equal sign. Yeah, I think so.
What's supposed to be the sign?
Number 3, the plus.
Wait, no, it's not.
No.
It's going to be
Upside. Because it's not.
Well, what's happening from here to here? Right, so now you decide, is it include it with the X or is it outside? Is it gonna be a up and down movement or is it gonna be a left and right movement? So we do that.
Tell me who you guys are. Tell me your studies.
Right, so
Parts of
when
it.
you do that,
So probably we'll start at 6.
Yep, it's a reflection, but then it also is 2, so that's going to be a vertical stretch. It's to be vertical stretch with the reflection. That's what you're doing.
Wait, but isn't that less than 1? So how did it
So if you ignore the negative, only shows reflection.
Okay.
Don't think of the negative as the number in front. Remember, the number has to be between either 0 and 1 or greater than 1. It can't be negative for the stretch and compression. The negative just makes it flex. So ignore the negative. 2 we're going to do what? Stretch or compress. Stretch, so vertical stretch. And the negatives is just going to make the whole thing reflect over the x-axis. So it's going to stretch vertically and
So
then
you
reflect
just write
over the x.
stretch,
Yeah, vertical stretch.
So, picture it stretches, it would be that
Yeah.
with
Yeah,
function.
that's okay. You want us to write there as well?
Yeah, yeah. All right, let's go over some of these. Some of you guys are asking questions. Number 1, what you guys come up with?
Left, 7.
Left 7.5 units. Number 2,
Up,
up
7.
7.5 units. Is everybody okay with those two?
Yeah.
The difference between them. Okay. Number 3, the 52 is inside with the x squared. So is that going to be a vertical or a horizontal?
Horizontal.
Horizontal stretch or compression?
Compression.
Yeah, horizontal compression. All right, so now number 4, we've got 2 different things happening. We've got a negative, which means it's going to reflect over which axis? Reflect over the x-axis. And then if we ignore the negative and just focus on the 2, is that going to be a stretch or a compression? Think about the 2. It's going to be a stretch vertically. So we got a vertical stretch. Sorry, my E and my C look the same there. Okay, number 5, what's happening? This 14 is going to do what?
Vertical stretch.
Vertical stretch. And the plus 6 is going to make it
So up.
up 6 units. Number 6, what's this 12 going to do?
Move it to the right.
This
Right,
12?
7. Oh, the 7.
Vertical stretch again. And then the minus 7 inside
Right, 7 here.
is going to be right. Right 7 units. Okay. Number 7. What's happening?
Gonna translate left.
Yeah. That plus 21 is going to make it go left 21 units. Eight, what's happening? Yeah, vertical stretch. Number 9, it's going to be a horizontal something. It's going to be a horizontal stretch. Good. Good spell. Okay, 10.
Up,
Up.
13.
Yep, up 13.7 units. Number 11, we got 2 things happening. Reflect over X. And vertical stretch. Good. Number 12, what do we have going on? Vertical stretch and
Up.
Right.
yeah, that's going to make us go right 8 units. Ooh, okay, now we're working in reverse. Now they're going to give us the transformation. We have to come up with the function.
Okay.
So if we give us f of x, we're going to create g of x. If it needs to be reflected across the x-axis, what do I need to add to this?
A negative.
That's it. Done and done. 14. G of x is equal to. I need to translate 7 units to the left. So does that need to be inside parentheses or outside? Inside, okay, and then just put your fifth power out there. Is it going to be x plus 7 or x minus 7?
Plus 7.
Good.
How do you know when to move the exponent?
If it's left or right, then we need to include that 7 inside with the x, then it would be on the outside. If this would have said up 7 units, then it would have been that, right? All right, number 15, we're going to stretch horizontally by a factor of 26.
Would it be square root?
It'd have to be cube root instead of 4.
Oh, yeah. Maybe?
No,
Cube root.
cube
Nope.
would be.
X to the 4th. For a stretch horizontally, do we need it to be larger than 1 or in between 0 and 1? It has to be between 0 and 1, right? We didn't go over this, but that's okay. It's going to be 1 over 26. I'm not going to give you one like these.
Okay, good. Wait, are the backwards ones going to be on the top?
No.
Okay.
So let's skip 16. Let's skip 17. 18, what will we do? That was an easy one.
Minus.
Yeah, x to the 3rd minus 33. So for the test, you're going to be given ones like the top half. What's the difference between F to G? So I'm going to allow you to do the following. For your test tomorrow, I will allow you to write whatever you want on an index card, 3 by 5.
One side, both sides.
Huh?
Both sides.
I will let you do front and back.
Okay, good thing.
So I'll help you study. Okay. So you might want to put these things down on it. You might want to put some of your number stuff from the beginning of chapter 2 on it. So are there any questions from that packet? I'm going to let you keep the packet. I'm not going to hold on. Grab
Yeah,
that.
can you go over this whole page right here?
Yeah, that was confusing.
That whole
Piecewise
page.
functions?
That whole page, yeah.
I thought we did a lot of piecewise functions. No? All right. So is everybody okay with their numbers? Look over that quiz, because the quiz is going to be, the test is like the quiz, true, false questions. A lot of you guys got some errors from that quiz when we took that back in the beginning of the chapter. So make sure you've got your true, falses down. We're okay with order of operations. Properties, that might be a good thing to put on your index card. All the different properties. These you just evaluate using your calculator. Those should be pretty easy. Exponent rules, that might be something you want to put onto your index card. Domain and range, are we okay with those? How about this one? What's my domain? It's going from, I can't even read what that says.
-3 to +3.
And then my range would be,
5 and 14.
is that what it is? 5 and 14. Okay. Identify whether it's a function or not. Vertical line test. What does the horizontal line test test?
If it's inverse, then.
If its inverse is a function. Okay, you have to do that. Make sure you've got your operations of functions, specifically your composition of functions. You guys did pretty well with that. Finding inverses. Remember, you switch your x and your y coordinates. Bree, put the phone away, please. There's 7 minutes left of class. Switch your x and your y's. Put it into slope-intercept form. Verifying, you're going to have to do that on the test.
Oh, how do you find the inverses of, like, to get x, to have them both equal x? How would you do
Oh, you
that?
do compositions both ways. So I would have to do f of g of x and then g of f of x. So if I plug this into there, 2x minus 2 squared,
Okay, this one.
2x minus 2, 2x minus 2, 4x squared minus 8x, 9 plus 4, which does not go to x. So there's no way that they're inverses of each other. They would go to x. Graphing a function and then its inverse. Are we okay there? Horizontal line test, we already talked about that. Piecewise functions. Number 51, if I plug in 2 here, what do I get?
-4, -3.
Closed dot, so that 2, -3, I'm going to put a closed dot. From there, my slope tells me to do what? So I can either go down and to the right, or I can go up and to the left. Which direction do I want to go? I want all x's to be less than -2, so I'm going to go in that direction. For the second half, plugging in 2, 8, 9, so 2 9s, somewhere up here, right out of space. From there, my slope tells me to do what? Up 4 over 1. Does it fit on the graph? Okay. So for this one, you would do 0, 0, closed dot. Slope tells me to go up 1 over 1, but I want to go in this direction, so it'd be over here. Here I get 0, 0. Slope tells me to go down 1 over 1. It's not going to look like that.
That one was easy.
Yeah, that's an easy one. Absolute value, honestly, the easiest thing for absolute value would be just to make your x and y table. So, well, let's think about this. If I were to translate that, this is going to tell me to do what?
So up to
This means
left 2.
left 2 and down 3. So I'll put it up here so I don't have to scroll. So if I start in the middle and go left 2, down 3, there's my vertex. The slope of my absolute value is just 1. There's my graph. But if I made a list of ordered pairs, -3, -2, -1, 0, 1, 2. -3 plus 2 is -1. The absolute value of -1 is 1. 1 minus 3 is -2. -2 plus 2 is 0. 0 minus 3 is -3. 1 minus 3, -2. 3 minus 3 is 0. 4 minus 3 is 1. And then you can just plot those points. -3, -2. -2, -3. -1, -2. 0, 0. Or 0, -2. And so forth. Okay. The only other thing that was not on here, there is a problem for a step function, so make sure that you can graph a step function also. So if I had to evaluate 2.1, what would that be?
3. No.
Round down or round up?
Oh, round down to 2.
Round down to 2. If I had just the top hat,
And then it'd be 3.
then it would round up to 3. And then make your step functions. So make your intervals. So -2 to -1, -1 to 0, 0 to 1. If I was rounding down, so if it was y equals the greatest integer of x, then my equals would be here, and that's where my closed dots would be, and then open dot. Okay. All right, so fill out that index card. I think that'll be a good way to make sure you guys study. I did print out, this is a resource from our textbook. It's the mid-chapter assessment, so it's just practice problems on sections 1, 2, 3, and 4. So it's missing 5, 6, and 7, but if you would like to pick that up for your own benefits, I'm not going to be checking it. Use the chapter reviews in the back of the chapter for practice problems.
Okay, my
good to go. And you won't have to do the reverse, given the graph to make the piecewise function.
Okay.
Only graph.
I was like looking at that and I'm like, okay, I'll just look it up in my notebook, but nobody told me that. Same though.
Double checking your part.
Bree and Erica, I need to talk to you ladies. So, why'd you guys leave early?
Because I needed to catch a ride.
There's lots of people who need to catch a ride. So, when are you guys making up your teacher detention? She didn't specify a time. She said you guys were just going to check in. So, Friday?
That's what I don't know. Maybe
Did she say Friday?
no, she didn't tell us a specific time. Oh, I don't.
Do you want to? I don't care which day it is. So, you guys pick which day works.
How long would it be for?
2:50.
Thursday. I can't do Tuesday. Okay.
Then tomorrow or Friday? Or today?
Friday?
Sounds like a plan.
Do you have any extra packets for me today? If you don't, like, do I need it? Like, are you gonna check it?
I'm not. If you want extra practice, let me print it out because I didn't get them back from whoever I gave it to. Let's go pick it up at the printer.
Following students, please pick up messages in the office.
What's your game last week?
Charisma Parker.
Tomorrow? Yep. First half, I'll tell you what.
Jacob Sansusi.
Thank you. You're welcome.
Would Ryan Mundell please report to H156? Ryan Mundell to H156, please.
Hey, Miss Crowley.
Hey,
I have a vote field trip tomorrow, so I won't be here for class.
you have a what?
I have a vote field trip tomorrow, so she knows, so I won't be here for class.
That's fun. Well, if we're gonna do some proofs, I can give you.
Sure.
we're going to work on. We are going to have a quiz on Friday on 4, 5, and 6. We're going to do these proofs together as a class, and we're going to work on this and then finish it for homework and study for the quiz. Okay? You're welcome.
Somewhere else, still here. This room is locked.
I don't know. He teaches period 7. You can sneak through if you need to put something in the room. I don't know where he would be.
Christina Coda to F101, please.
Thank you.
You're welcome.